Hey, it is me, Kanye West, and today I will be explaining the electrical concept of power and energy. Power can be defined as the rate at which energy is used. It is measured in units of joules per second, which is watts. Energy in electrical engineering is the work done by the electrons in the circuit, and is calculated by multiplying power by time, and its units are joules. Now it is time to gain an understanding of how power is related to voltage, current, and resistance. Voltage can be defined as joules per coulomb, and current can be expressed as coulombs delivered per time. If we were to multiply these two expressions, we are left with joules per time. As a coulombs cancel out, as lived before, power is defined to be joules per second, and for power is equal to voltage multiplied by current. Ohm's law, for those who don't know, is voltage equals resistance times current. Can be used for substitutions to make more equations from power equals voltage times current. If voltage over resistance is substituted for current, power can equal the square of voltage divided by resistance. If current multiplied by resistance is substituted for voltage, power is equal to current squared multiplied by resistance. Now I will go over a few example questions. If the power dissipated by a resistor is 250 watts and the current that runs through it is 5 amps, what is the resistance of the resistor? We can rearrange the equation power equals current squared times resistance to be resistance equals power on current squared. If we substitute the values in, we find that the resistance would be 10 ohms. Here's another question, it is a bit harder. A 30-watt light bulb's kilowatt hour costs 50 cents. How much does it cost to keep the bulb on for 1 year? First hours you are needed since there are 365 days in a year and 24 hours in a day. The hours needed will be equal to 365 times 24, which is equal to 8,760 hours. We then multiply the time by the power, which is 30 watts. So 30 times 8,760 is 262,800. Since the question is asking for kilowatt hours and there are 1,000 watts in a kilowatt, we divide 262,800 by 1,000, which would be 262.8 kilowatt hours. Now we just multiply this values by the cost per kilowatt hours, which is 50 cents or $0.5, and so it will be $131.40. Before I end the lesson, just remember, no one man should have all that power. That is the end of the lesson. Thank you.